From the bend of the sea, what is into the wall? Like a distant scream, and one guitar, it blew him away. Stars in his eyes, the very next day, gonna beat up 6, some second-hand store. Didn't know how to play, but I knew for sure. The one guitar, it felt good in his hand. The midnight love, the understand. One guitar, from way down low, with one rating, only one way to go. They started rocking, never gonna stop. We gotta keep on rocking. He's gotta make it through the top. And be a jukebox hero. He's a jukebox hero. One guitar hero.
Okay, hi there. Today I'm going to be covering for pre-calculus, I'm going to be covering graphing, parabolas, and leading coefficient test. So first thing is there's a couple of equations here for for parabolas. First one is vertex form, which is like this one right here, y equals a times x minus h squared plus k, right? So that's vertex form. The other form for parabolas is standard form, which is y equals ax squared plus bx plus c. All right, so if you're looking to find the vertex for those two forms, in vertex form it's given to you. You just pull the h and the k right out of the equation. The h is the opposite sign of what you see in there, so if you see x minus 4 in there, the 4 will be positive. The k is the same sign as it looks like. So if I had y equals x minus 4 squared plus 2, the vertex would be 4, 2, okay? In standard form, it's a little harder to find the vertex, but there's a formula. It's x equals negative b over 2a. So you plug in b and a and simplify and get the x coordinate, and then define the y coordinate. You know, say I got x equals 2. Once I simplified that thing, I'd take the 2 and I'd plug it in for all the x's over here, and for that x and that x, and then find out what the y coordinate is. All right, so that's basics on parabolas. The other thing is that if a is positive, the parabola is going to open up. Okay, both arms will be going up on the parabola. If a is negative, it'll be opening down. Both sides will be falling down to the left and the right, which is part of end behavior, which is something we'll also be talking about during this video. You know, with the how a graph looks with parabolas and various other shapes as well. So anyway, a is going to play a role. Okay, so that's the basics with that. Now, next, I'm going to show you how to graph with vertex and xy intercepts. So suppose I had this one here first. Let me start with the vertex. So like I said before, hk will be your vertex. Okay, so since it's plus 3 here, it's going to be the opposite sign for the x. It's in parentheses. That's another way to think of it. The y will be exactly what it looks like over here. That's also the y-intercept, the leading thing. Wait, my mistake. That's not going to be the y-intercept. Once I multiply it out, the constant term will be the y-intercept. All right, so let me get back to this. So I know what this is. I know what the vertex is. I'd like to know the x and the y intercepts. So x and y. So if I go 0 and 0 and plug them in, you know, what do you get? I already know that so for me to find the y-intercept, let me plug in 0 for x, which will give me 0 plus 3 squared minus 1 will equal my y-intercept. Okay, 3 squared is 9, 9 minus 1 is 8. So that's what I get there. If I go the other route and I plug in 0 over here, when I have this one, where I'm plugging in 0 for y. I'm going to multiply this one out. All right. If I FOIL this out or use box technique, I happen to know the perfect square formula, which means you square the front, square the back. The middle term will be what I get when I multiply the two terms together and then double it, which is 3 times x, which is 3x times, and when I double it, that's 6x. So I get this, okay? Which means if I subtract 1 from 9, I get 8. So I got x squared plus 6x plus 8 equals 0. Now I can factor this. That's a piece of cake to factor, because things that multiply to 8 and add up to 6 are 4 and 2, which means my x-intercepts are -4 and x equals -2, because I could have gone x plus 4 equals 0 and x plus 2 equals 0. Solve those two things and get those two, -4, -2. All right, so now I got that. -4, -2. So let me go do a quick graph over here. Do it blue. This doesn't have to be a great graph, nor will it be. Axis over a little bit. All right, so my vertex we said was -3, -1, which we'll say is here. -3, -1, and then it's going to cross the x-axis at -2 and -4. Oh yeah, one more thing. I made a mistake up top there when I said the y-intercept. The y-intercept is going to be 8. Okay, because so I should make my parabola here hit 8. I'm going to say 8's right here. It's going to go through here and then go through there. Okay. This is the constant, and that's the y-intercept. When it's in standard form, the y-intercept is that. Okay. All right, so that's the first one. Also, one more thing. If I gave you this instead, and you need to find the vertex, I'd go -b over 2a. Remembering a is 1, okay? That's a. B is 6. C is 8. Okay, you're not going to use C, but if I go -b over 2a, that's -6 over 2 times 1, which is -3, and then I can plug in the -3 here, and I'll find out what the y-coordinate of the vertex is. So that's 9, that's -18, that's 8. When I add those together, I get -10 plus 1 is 1, -1. So see how, sorry, that should be a y, not an x. My vertex is still the same thing. -3, -1 would be my vertex, and that's how you'd get it if they give it to you in standard form. If it's in vertex form like this, it's beautiful because you just pull it right out, okay? But you can get it that way too, okay? So either way, that's how you get the vertex. All right, next one. This one, they gave it to me in standard form. So I'm going to have to use the vertex formula first because that's what I want to know. X equals -b over 2a. B is 8. A is 2. So I get -8 over 4, which is -2. So that's my x-coordinate. Now to find the y-coordinate, I plug that -2 back in here for my x. -7, and start simplifying. Okay, so -2 squared is +4. Notice how it's in parentheses, big difference there. Yeah, and 4 times 2 is 8. And if I take the 8 times -2, I get -16 minus 7. Combine all those together, and I get y equals -15. So there's the vertex. All right, now I'm going to do quadratic formula over here on that because things that multiply to negative, it looks like it's going to be hard with 2 in the front, -14. I'm not even thinking of any factors. So remember the quadratic formula always works, factoring sometimes works. So A is 2, B is 8, C is -7, and I can plug this into x equals the quadratic formula, -b plus or minus the square root of b squared minus 4 times A times C all over 2 times A. All right, start simplifying. I get -8 plus or minus the square root of 64 plus 4 times 2 is 8. 8 times 7 is 56. All over 4. So x equals -8 plus or minus square root of 120 over 4. And then I can break it up to the plus, the minus. X equals -8 plus the square root of 120 over 4. X equals -8 minus the square root of 120 over 4. I'm looking for decimals, all right? So when I punch those in, I get either 0.47, 0.74, or -4.7. Okay, so now I got my x-intercepts and I got the vertex. If I look back at the original equation, A is positive, so that's going to open up. Okay, so it's up and up will be the end behavior. So if I graph this quickly, my vertex is -2, -15, so we'll say that's way down here somewhere. And it's going to cross the x-axis at 0.74 and -4.7. Okay, so that's where it's going to hit. And make a quick graph here, hitting there, here. And did we figure out what the y-intercept was? Oh yeah, that's right. Remember, it's right there. It's -7. So that's where this is hitting. In case you couldn't tell, that's -7 on the graph. And we'll just leave it like that, even though I know it's not. It doesn't look like it's -7. It's not bad. It's about halfway between 15 and 0. All right, anyway. So that's that problem. Next, if I give you this one, I'm going to find out the vertex and the y-intercept. The y-intercept is easy, right? That's going to be -14. And the vertex, once again, -b over 2a. -b over 2 times a is -1, because there's an implied 1 there, okay? And now if I simplify that, I get -8 over -2, which is +4. So I get 4 is the x-intercept. Got to find the y, so I'm going to plug it back in. It's 8 times 4 minus 14. So this is 16, and then I make it negative. Notice how the negative sign is outside. So I'm not plugging in -4, I'm plugging in +4. 4 times 8 is 32 minus 14. And when I combine those all together, I get 2. So that's the y-coordinate of the vertex. Okay, and once again, I'm going to do quadratic formula with this because there's nothing that multiplies to -14 and adds up to 8. I'll tell you right now. So -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a is -1. And that's what x equals. Okay, so if I start simplifying this, notice how many negatives I got here. It's always worth a moment to check that out. I got 3 negatives, which means that's going to be a subtraction sign. So that's 64 minus 4 times 14 is 56. So that's -8 plus or minus that all over -2, which gives me -8 plus or minus the square root of 8 over negative 2. And if I break that up, I get my two answers of 2.6 and 5.4. Okay, so I'm going to graph this one next, and so since A was negative on this is going to open down. So these are my x-intercepts, 2.6 and 5.4. And the vertex is at 4, 2. Four, 2, so that's a 2, not a 4. And so now I said it's opening down because A was negative. Okay, so I'm starting here, hitting those x-intercepts. And there we go. Okay, and there's your graph. The y-intercept would be negative 14, so I can fix that too. We'll make this eventually hit negative 14 down here. There, okay? All right, and there's my graph. All right, next, problem solving. This is a real world kind of problem. Anytime there's a parabola, there's a, anytime there's a projectile, something thrown through the air, you know, shot up into the air, that's going to be a parabolic kind of shape, a parabola. So, for example, this one's about a football getting punted, which will be a parabola. Okay, that's what your punt will look like. A baseball thrown, lots of sports kind of things are applicable here. So the height y in feet of a punted football is given by the equation y equals negative 16 over 225 x squared plus 9/5 x plus 1.5, where x is the horizontal distance in feet from the point at which the ball is punted. What is the maximum height of the punt? So you can see I never got an A in art, and you can probably see why. There's a punter on the left side and the football on the right, and and I need to know what the maximum height is, which is going to be, has to do with the vertex of the parabola. Okay, so I need the y coordinate of the vertex to find my answer. So if I can find that, I'll be good to go. All right, now this one seems like kind of a nightmare because of those fractions, but let's take it step by step. So it's standard form, which means I need negative b over 2 times a, where a is negative 16 over 2025. B is 9/5. Okay, so if I plug those in for a moment, I get negative 9/5 over 2 times a is negative 16 over 2025. So I get that, all right? Okay, so I plugged in those into my calculator, the negative 9/5, and then 2 times 16 over 2025, I got negative 1.8 over negative 0.01582. And if I divide those numbers out, I get x equals 113.78. Okay, so that's the x value. Now the y value is what I get when I punch that in over here. I'm going to round that off to 0.8, okay? So 113.8 squared plus 9/5 times 113.8 plus 1.5. All right, and then I'm going to punch that in my calculator. And when I do that, When I punch those in my calculator, I get the negative 102.3 plus 203.4 plus 1.5. And if you add those three things together, you get approximately 102.6 feet. So that's what I'm going to leave my answer as, which would be the maximum height that that ball was kicked. All right, so it was the y coordinate of the vertex. Next one. A manufacturer of lights has a daily production cost of C equals 800 minus 10x plus 25x squared, where C is the total cost in dollars and x is the number of units produced. How many lights should be produced each day to minimize cost? Okay, so this one, sometimes a graph helps with these. If I was to do a quick graph, I know this is going to open up because this is the biggest number in the degree of the polynomial, so it's going to open up. I don't know where it's going to hit, and I don't even have to put the crossbars in there. I know it's going to just open up. Okay, which means I'm looking for the minimum cost, which will be down here, the vertex of the parabola once again. All right, and this is actually going to be the x value, because x is the number of units produced, and they want to know how many lights or units should be produced. So because that will give me the minimum. Okay, so if I take that equation, I'm going to switch this around for a moment just because I don't like that. I like the x squared first, I like the 10x second, and I like the 800 third. Okay, so x equals negative b. So I got a double negative, that'll become positive, over 2 times a. So that's 10 over 50, which gives me 1/5, which is, so sorry, I had a huge typo. Instead of being 25, it should have been 0.25. So we're going to change our notes there, come back down here, make that 0.25, and then this 0.25, and then I get 10 over 0.5, and when I divide that out, I get 20. So that's how many units lights should be produced. Okay. All right, so that's the answer. I don't have to get the y value because it was just the x's. All right, next, I'm going to show you guys a couple things. Write these down, please. Leading coefficient test. This has to do with two things. End behavior, what's going on with the graph? Is it going up and up? Remember, we look at the left side first and the right side second. This graph is f of x equals x squared. So the highest exponent term is a 2. It's x squared, and so that's even, which means they're both going to be up and up or down and down if the exponent is even. And in this case, the leading coefficient is a 1, which is positive, which means it's going to be opening up and up. Right? If it was negative 1, they'd be going down and down, or negative anything. Okay. And this would also be true for any exponent that's even. Okay, if the biggest degree of the polynomial is even, then it's going to be up and up if a is positive. Okay, so for example, if I gave you, f of x equals 3x to the 6th minus 2x to the 5th plus 3x to the 4th minus x cubed plus 1, this is going to be the exact same type of thing. All right, it's going to be up and up. The graph may not look exactly like a parabola, obviously, but the end behavior will be the same, and the two ends will be up and up. Okay. Next one. If f of x is equals negative x squared, end behavior is down and down. The highest exponent is even. Okay. Because you can see that not only is the exponent even, the leading coefficient is negative. There's an implied 1 in front of there, right? Which makes it negative 1. So since it's negative, it'll be the opposite, down and down. So this will be true not only for x to the 2nd, but anything that's got x to the 4th, x to the 6th, x to the 8th, any even exponent like that. So an example would be f of x equals negative 2x to the 4th plus 2x to the third minus x squared plus 3. That's going to have the same kind of end behavior. They're both going to, the ends will fall to the left and to the right. Next one is down up, right? Y equals x to the third. A is positive, there's a 1 in front of it. And it's an odd exponent. This is the one, if you memorize this one, that snake going down to the left and up to the right. That's this, okay? Down and up. I don't know how it turns out on my camera. It might be backwards, but because the things get flipped around on the camera. But the left side is down and the right side's up. That's down up, okay? We do the left side first. Second side second. So I say down and up. Okay, so an example, and this will be true for anything that's got an odd exponent and a positive coefficient on it, which would be, for example, f of x equals 3x to the fifth minus 3x to the fourth minus 3x to the third minus 3. It doesn't matter what else is there as long as there's no exponent bigger than 5. This term right in the front here is the only thing that matters that we're focusing on, because that's going to determine how the ends of the graph go. Next one and last one is up and down. So this is the same kind of thing, except a is negative because there's a negative 1 in front of that x to the third. So the highest exponent is odd and the coefficient of the term is negative. So it doesn't matter if it's, negative x to the third or negative 4x to the third. This will be the same thing, plus 2x squared minus x plus 1. This will have the same kind of end behavior and the leading coefficient test. All right. And that is all I got for today. I'm going to close it out with a little bit more music. Have a great night. Shadow by the backstage door, like a trip to the past.